Hey y'all, this lesson is to help you find the area of a non-right triangle. We know from geometry that the area of a triangle is 1/2 of the base times the height. We can use trig to help us derive the area of a non-right triangle. So basically, instead of just giving you the formula, I'm going to show you where it comes from because that's fun. So we have this triangle and we've dropped a height from B to the base of the triangle. And we're going to use the smaller triangle to kind of help us find what the height is if it's not given to us. So pretend like that height is not there. We were given the larger triangle on the outside. I can show you what that is. The larger triangle on the outside, and we need to find the area. Well, to find the area, we have to have the height. And if we don't have the height, we have to find the height. So we can use the existing formula for area, and we're going to call it K in this case. And then, excuse me, the height can be found using this smaller right triangle. And we can say that H is going to be equal to, excuse me, back up. We're going to do, if we can envision this as the hypotenuse because it's across from the right angle, and we're going to use angle A, this would be the opposite side. So if we were given this side, because we were given the larger triangle, then we can say sine A equals opposite over hypotenuse. Write that down. Sine A equals opposite, which is height. Sorry, let me change that to height over hypotenuse, which is C. So then I can manipulate the equation a little bit, multiply both sides by C, and that's going to give me what you see right here. We substitute height for C sine A, which were pieces that we would have been given for this problem. And then I can drop the parentheses and I have our new formula that we're going to be using today. This is the important part. K equals 1/2 of B, which is the base, times C sine A. So if you've got two sides and an angle, then you can find the area of the triangle. Now, all this was just getting to the formula that we're going to actually be using. I just wanted you to know where that came from, because it's easier if you don't have that formula handy, it's easier for you to come up with. So we have a triangle, ABC. We can just draw that. Whoops. A, B, C, where C is 62 degrees, B is 23.9, sorry, angle C is 62 degrees, side B is 23.9, and side A is 31.6. So the area of the triangle is 1/2, well, okay. The way I drew my triangle, it doesn't line up with my formula, but I'm going to show you that it's going to turn out just so that if this happens to you, it's going to be fine. But basically the formula is saying 1/2 of the two sides given with the included angle. So even though I labeled my triangle wrong, we're going to keep going. The two sides given and sine of the included angle. So it works out. If that really bothers you, if you don't like that at all, you can relabel your triangle. We have the power to do that. That's totally fine. So we can call this A, and then this B, and this C. Dun, 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 fixed it. So it applies. This is side C, this is side B. So now when you plug it in, it all works out. 1/2 side B times side C times sine, that sounds weird, A, included angle. And then you can just type that in and make sure you're in degree mode. when you do type that in, since we are talking about degrees in this case. So we have 1/2 times 23.9 times 31.6 times sine of the included angle. And we get an area of 333.42. And I was not given the units, like whether it was inches or feet or centimeters or anything. So I'm just going to say units squared. Remember, this is area. So your units are going to be squared here. For example, or just to explain that, if this were 31.6 units and 23.9 units, when you multiply units times units, you get units squared. So there's that. Okay, moving on. We have an example. The Triangle Hotel recently installed a triangular pool. One side of the pool is 24 feet, another side is 26 feet, and the included angle is 87 degrees. If the hotel manager needs to order a cover for the pool and the cost is $40 per square foot, how much can he expect to spend? So if the cover is covering the entire area of the pool, we're going to have to first find the area of the pool, and then we're going to have to multiply it by how much it costs per square foot. So that square foot is kind of your indicator of the, oh, this is area. So you can draw a picture if you want to. In this case, we already kind of know the formula, so we don't really have to, but we'll just go with it. One side is 24 feet, one side is 26 feet, and the included angle is 87 degrees. So my formula says we're going to take 1/2 times the product of the two sides times sine of the included angle. And you can type that in and get the decimal approximation. And we get 311.57 feet squared, or square feet. Now remember, that's not the end of the problem. The end of the problem is asking how much is he going to spend on this pool cover. So now we're going to take that and multiply it by 40. And let me write that down so we don't forget it. Times $40. We get about $12,462.90 if I were to round that. That's it, an expensive pool cover. So that is how much it would cost to do that cover. That's all you have to do. Find the area of the triangle using your sine function, multiply by how much it costs per square foot, and there you go, grand total. So let's say we have a situation where we know 3 sides and no angles. And it's not a right triangle because we don't know any of the angles. So we use Heron's formula, and this formula is derived from using the area from above, Pythagorean theorem, and the law of cosines. I'm not going to go into that for the lesson. I think it would be too much for this lesson particularly, but if you want to look that up, you can, it's in the textbook, or you can probably Google that and you're going to find it. But basically, long story short, the area K is the square root of the S times S minus A times S minus B times S minus C. You're probably wondering, what is S? S is found by half of the perimeter. So you are going to, you might want to write that formula down if you don't have it. So if you have a running sheet, go ahead and write that down. The first thing you have to do is figure out what S is. And in order to figure out what S is, you have to find the perimeter. So if you have a situation where you're given a triangle, it is not a right triangle, and you're trying to find the area, start with the perimeter. So we're going to add all 3 sides, 23 plus 46 plus 41. Then for S, we're going to take half of the perimeter, which was 110. I don't have units, so I don't know if it's inches, feet, whatever. And that's going to be 55. And now that I have S, I can just plug it into the formula. K equals the square root of S times S minus A times S minus B times S minus C. It's a long formula. Let me make sure I've got that written down correctly. S times, yep, got it. Okay, and then we just plug it in. Forgot my parentheses. K equals square root of S, which is 55, times 55 minus the first side, times 55 minus the second side, times 55 minus the third side. Extend that square root, and then we can just type that in. When you type that in, you should get 470.9 or 0.91, depends on what you're going to here, units squared. Remember, we're talking about area, so it's squared. And I want to show you where this comes from so that logically you know why that works out. Let me reduce that. So inside the square root or underneath the square root, we have 55 units times 55 minus 23 units. So basically, this is units times units times units times units, which is units to the fourth. But when you take the square root of units to the fourth, you end up with units squared. So that's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I will see you in the next one.